question 13. 13, okay. Question 13 now. And then question 16. Okay. Okay, I'll just do a quick one over question 10. It's not much, not many to ask from it. Okay, question 10 is about your connected rates of change. So it's about being able to form that equation, that formula that you need. Okay, so question 10 itself, they have given you that y equals to cosine square x plus 1 quarter, and it is being defined between 0 and pi over 2. Okay. You are also given the information that x is decreasing at a rate of 0.5 radians per second, but because it is decreasing, we need to realize that it is a negative 0.5. Okay, so I want us to take note of that, and we want to find the rate of change of y, that means dy over dt, when at a specific y value that is equals to 1. Okay? So in order to solve this, first thing that we should be doing is to find out what is dy over dx. And in this case, we will get 2 cosine x. Then after that, differentiate the cosine, you will get negative sine x.
Still correct.
Differentiating 1 quarter is 0. So upon simplification, this is what you get. Okay? You could actually further simplify this 2 cosine x sine x by realizing that it is your double angle formula, that is your negative sine 2x. Okay, so you can look at the formula book that I gave you. That is that trigonometric identity over there. Okay? Then the question asks us to find out what is dy over dt. So the formula that we will need is dy over dt equals to dy over dx times dx over dt. And that would be negative sine 2x times your dx over dt, negative 0.5. And this gives us half sine 2x. Okay? But the question asks for the value, okay, of this itself when y equals to 1, but I need x value instead of y value. So to find the x value to put inside here, I will need the corresponding y value from the original equation. So we're looking at cosine square x equals to 3 quarter. In other words, when we take square root, that is your positive and negative square root 3 over 4, which can be simplified to plus minus square root 3 over 2. Okay? You need to be sensitive to square root numbers, especially when it comes to trigo. Anytime when you see square root 2 or square root 3, most likely it is your special angle. Okay? To recognize a special angle for the angle itself, right, you can use your calculator, use it in degree mode to see what is the degrees itself. In this case, the degrees will actually be 30 degrees. Okay? But then we want to work things out in radian because this is in radian here. Okay? So our basic angle, which is found by taking cosine inverse of the positive value, that will be pi over 6. 30 degrees is pi over 6. Okay? So, because the question has given us that the interval is between 0 to 90 degrees, okay, and your basic angle is 30 degrees. Anything more than that, so if you look at your ASTC, okay, in this case, it is plus and minus, that means it's all quadrants. Okay, your basic angle lies inside your first quadrant. To find your second quadrant angle, it will have to be pi 180 degrees minus away basic angle, and that will be 5 pi over 6. And 5 pi over 6 would actually be 150 degrees. This is more than pi over 2 already. So surely we reject it. Okay, so this one reject already. Since the second quadrant already rejected, third and fourth will naturally also be rejected. Okay, so since this is the range, x can only be pi over 6. Okay, so this part over here is just my explanation to you. Okay, over why we are stopping at x equals to pi over 6. Okay, then now that we have x value, we need to find out what is the dy over dt. So this one you can press, no, let's not press the calculator. Let's learn how to do exact also. Okay, so this is sine pi over 3. So pi over 3 is your 60 degrees. Okay, so 60 degrees is here. From the right, from counting from the left, that's square root 3 over 2.
Pi over 2.
So your answer will be root 3 over 4. Okay, and hence y is increasing at a rate of square root 3 over 4. Square root 3 over 4, sorry. Radian. Is it radian? No. It's just units per second. Okay. Why is it not radian? That's because your y is being defined such that it is the value that comes out of this. X is the one that's an angle, then it should be radian. But y is the ratio that comes out, so it's just units of it, okay? Okay, because y is not an angle. Right? You can just say that y is the rate of change of y is just square root 3 over 4 units square root 3 over 4 units per second. You need not tell me that it is increasing. Okay? But because this the question didn't ask whether is it increasing or decreasing. So this is just an additional part. Okay? Just an additional piece of information for us. You check your own work, although many of you didn't ask, okay, that you are getting the correct answer itself. Any questions? Yeah? Then question 13. Yes. In decimal, right? Okay. What is it in decimal? Square root 3 divided by 4. You get 0.433 is fully perfect. Okay, nothing wrong with it because the question didn't ask for exact value either. Alright, I just want us to actually practice, okay, doing this in exact because you never know that the question may ask for exact values. It is always easy to find decimal values, but it's not easy to actually find exact values. That's why we need to actually practice them. Okay. Question 13. Okay, for question 13, right, they gave you y equals sine 3x over 2 minus cosine x, cosine 3x for 0 to pi. Okay, we want to find the x coordinates of the points. for which the tangent is parallel to the x-axis. Okay. Now, first thing we must be able to interpret from the question itself is what does it mean when tangent is parallel to x-axis? Or in fact, okay, if we narrow down the question, what is the gradient, okay, when a line is parallel to the x-axis? Okay, so for x-axis, it is actually a horizontal line, so your gradient itself is equals to 0. So because we're talking about parallel, that means your tangent gradient must be equals to 0 itself. Okay, so we're looking at dy over dx, which is your gradient of tangent, being equals to 0. Okay, so there's a piece of information that you must be able to interpret from the question. Then, from the given function, we will differentiate it using our quotient rule. So using a quotient rule, we keep the bottom, differentiating sine 3x, we get cosine 3x, not forgetting to differentiate the 3x, we get a 3. Then we keep the top, differentiate the bottom. This is a negative cosine 3x, so differentiating cosine itself gives us negative sign, but then there's a negative sign in front as well, so negative become positive, that's why we get a sine 3x over here. So this sine 3x is a result of differentiating your negative cosine 3x. Okay, then we differentiate 3x as well, we will get a 3. Okay, denominator squared. Then from here, let's try to simplify it so that it will be easier for us to work with. So 3 cosine 3x times 2 minus cosine 3x minus away 3 sine squared 3x. Okay, so this is at best that we could leave it 2, okay, without going too deep, right? We can just take this and then equate it to 0. That means your numerator must be the one that is equals to 0. Denominator cannot possibly be equals to 0. So we have this. Okay. Then we need to think about how is it that we can actually work out the value of x, because the question wants us to find the coordinates of x itself. Okay. Intuitively, you may think of wanting to expand it because there's no other way for us to get around it. And maybe there is, but for myself, I would think about expanding it, so let's try that. So upon expansion, we have this. Okay, I want us to be able to observe that with the cosine square and sine square, okay, it should ring a bell in terms of the identity to use. Okay, and that is actually your sine square plus cosine square. So we can factorize out the 3 first. Okay, and then we will be able to see this cosine square 3x plus sine square 3x, and that's equals to 1. Okay, so 3 times 1 is just 3. So therefore, we get a much neater numerator. Okay, so it depends on where and how you want to go about simplifying. You could have done the same on top here, but for me I didn't. Okay, Getting here, then the next step would just be bringing the 3 across and divide by 6. Okay, maybe let's not skip steps. So we're looking at cosine 3x equals to half. Okay, and half again is a result of a special angle. Okay, and that is your basic angle of 60 degrees, which is pi over 3. Okay. Then from the cosine equation here, because your value is half, which is positive, that means positive, we look at the first and the fourth quadrant. Okay, so first quadrant is just your basic angle. So 3x itself, we're trying to solve 3x first, because the angle here is 3x and not x. So 3x itself is equals to pi over 3 for the first quadrant. And in the fourth quadrant, we are looking at 2 pi minus pi over 3, and that will be 5 pi over 3. Okay? So this will likely be the standard, okay, that you are familiar with, okay, in terms of solving trigo equation. But the trick here is that question said x is between 0 to pi. Our angle here is 3x. So we need to manipulate the inequality by multiplying by 3 across. That means your 3x is between 0 to 3 pi. 3 pi will mean that we are going one round, that's 2 pi. Okay. For the third pi, that means we can still go another half a round. Okay. So in my first round, I have already identified the first quadrant and the fourth quadrant. Then I still need to go another half a round. That means it will meet my first quadrant again. So I have a third angle. That will be 2 pi plus the basic angle. Okay. So this is the part where most people tend to forget, okay, to check your intervals, check your number of cycles. Okay. Hence you will have 7 pi over 3 is. And therefore x would be equals to pi over 9, 5 pi over 9, or 7 pi over 9. Okay, where we divide each of the 3 angles by 3. Okay. Again, in this question, it did not specify for exact value, so it is okay if you leave it to me in decimal, okay, rather than in exact. But like I mentioned, we need to practice identifying exact. Okay. Questions? you a diagram that looks like this, saying that the one on top is an isosceles triangle and the one at the bottom is a rectangle. Okay, for isosceles triangle, we need to have the realization that I can divide it into two congruent triangles that are actually right angle. Okay, such that down here theta, down here theta, because it's congruent. Okay, then we want to find in part I, okay, the area of the entire figure. Okay, so in order for us to figure out the area for this rectangle itself, I need to know this length ED. Okay. And for this length itself, we also realize that it is the same as this length BC. Okay, so if I can find out what is BC, then I will be able to figure out the area of the rectangle. Okay, then I also need to figure out what is the area of the triangle. Okay, and that could be found by using, instead of half times base times height, we use the area of triangle formula, whereby it's half AB sine C. Okay, since I know this is 8 cm already, if I can find out what is BC, then I can use the sine angle over here. Okay, so that is the strategy that we'll take. So the challenge is, what is BC? Okay, so if I were to focus on this right angle triangle, AB, maybe I'll mark the halfway point here, X. This is angle theta, we know this is 8 cm. Okay, BX is actually half the value of BC. Using my trigonometry, this is your adjacent side hypotenuse, we can use cosine. So cosine of the angle equals to adjacent side BX over hypotenuse 8. And therefore BX is equals to 8 cosine theta. And hence our BC will be 2 times of BX, so that will give us 16 cosine theta. Okay, so now that I have BC already, everything will fall into place for us. Whereby the area S will be, area of rectangle is 4 times ED, which is 16 cosine theta, plus the area of the triangle, half AB sine C, so 8 cm, times your BC, that's 16 cosine theta, times sine theta. Okay, so hope you are familiar with this area of triangle formula. Must be two sides that kiap each other. Okay, the angle must be in between. Okay, so that's why 8 cm and this BC. And then we can simplify this, and we will get 64 cosine theta plus 64 again sine theta cosine theta. Okay, if you like to, you could actually factorize it. This is one way that you can present your answer. Alternatively, okay, from here you can also recognize your sine double angle. This is another way that you could actually achieve an answer as well, or present your answer. You could in fact further factorize it and get this. It's also fine. Okay? So any of these three options are possible ways that you can leave your answer to. Right? I want us to be familiar with these three answers. Why? Because you never know, okay, whether the question is expecting you to show towards something. Okay, this question didn't ask you to show towards something. Okay, so any of these three will be acceptable. But what if they want you to show this? Then we must know how do we arrive there, and that is by using our sine double angle. Okay. want to find out what is the value of theta for s to be maximum. Okay, so we can find out ds over d theta. The s that I will be using will be this one. Okay. So use your product rule. Keep left, differentiate right. Plus keep right side, differentiate left side. Your preference, it is okay to leave your answer at this stage for your derivative before you move on to letting it be equals to 0, or you want to actually continue and then simplify it. Okay. So for cosine square minus sine square, that is not equals to 1. Okay, oops, I forgot to put here. Okay, cosine square minus sine square is your cosine 2 theta. By the way, I don't expect you to memorize your double angle and then your sine double angle and your cosine double angle. All these are formulas that will be found in your formula list. Okay, but with practice you will get used to it and be able to recognize them fast enough. Okay, then I don't know whether you will commit to memory lah. Okay, but then you have your formula list to go back on to check. Okay. So arriving here, ds over d theta equals to 0. Can we get this? Okay. To know how to solve this, with the angles being different, okay, we are not able to simplify it to a single trigo function. So what you could do instead, since this is sine, okay, our cosine 2 theta, there are 3 different ways that you can present it. First way is your cosine square minus sine square. Okay, the other one, or rather the other 2, those are the ones I don't remember, so that's why I always refer to my formula. Okay, the other 2 would be your 2 cosine square theta minus 1 and your 1 minus 2 sine square theta. Okay, so in this case, if I want to convert my cosine, this one is actually in sine already. Okay, it will actually help us if everything is in sine or everything is in cosine. But since you're trying to change this towards your sine, so therefore I choose my 1 minus 2 sine square theta. So you need to strategize and know which one to use. Okay. Then and we arrive here. I'll make everything positive by maybe shifting everything to the other side. Okay. And we have this, for which I can divide by 64 throughout. So dividing by 64 throughout, I'll get 2 sine square theta plus sine theta minus 1 equals to 0. Need to recognize that it is a quadratic function and this is factorizable. Okay, so we will have 2 sine theta and plus plus minus 1, then after sine theta plus 1. Okay. Must show your factorization. And we have two sign values. Okay. So if sine theta equals to half, basic angle will be your pi over 6. Theta is equals to pi over 6 or else pi minus pi over 6 because we're looking at first and second quadrant. Okay? But as for sine theta equals to negative 1, if you press your calculator, okay, of sine inverse of 1, you get 90 degrees, that's pi over 2. But I want us to realize from our graph of sine, negative 1 is here. This is the angle that we're referring to, and this is 270 degrees. Okay, and 270 degrees is your 3 pi over 2. Okay, now we have to reject 5 pi over 6 and 3 pi over 2. Why? Because in the diagram given to you, angle theta is actually defined to be here. For this triangle to be isosceles, this angle here must be acute. If it is more than an acute angle, you confirm will not get a triangle anymore. Agree? Okay, so in order to have triangle, okay, or isosceles triangle, this one must actually be an acute angle. Alright? So, because you cannot get an isosceles triangle with obtuse angles. Okay, there are obtuse angle triangles, but it will not be isosceles on both sides to be congruent. Okay, so therefore, your angle itself for theta must be bounded by this interval, 0 to pi over 2. Okay, so this is the connection to the context itself. Okay, so if you are very skillful in doing all these steps, okay, in terms of solving and all that, one very important thing is the connection to the context. If you are not aware of the context, you wouldn't actually end up rejecting these two answers. Okay, so end up we only have pi over 6 that would give us a stationary value. Okay, and then to end off, we need to prove that this is going to give us a maximum, because the question wants an angle theta that would give us a maximum. Okay, so I'll continue here. Okay, second derivative. If you like to, you can differentiate this, but if you find this a challenge, then please just use first derivative test. Okay, using your second derivative, you should get this one. And that will give us about negative 110.85. maximum when theta equals to pi over 6. Curiosity and of course for me to understand. For this question 16, right, what was the challenge? Was it in terms of forming part I? Was it part I itself there was a challenge already? Is it? Just now, who raised hand? Just now it's the five people raised hand, right? Maybe was it part I? Who asked for question 16? Always like that one, you know. I always ask who don't know, then after that I go through the question, then after that I ask who was it the ones that raised hand, and nobody answer me. Okay. So I don't find yes part I could be challenging, but most of the time, right, they would have asked you to show something. Okay. So even if you don't know how to create that, okay, showing itself, okay, the formula is there already, so it shouldn't hinder you from going on to part 2. Okay. Part 2 itself, okay, I know that the challenge will really become in terms of maybe differentiating, okay, and then after that solving itself will be another challenge, alright? And then in this particular case, knowing what are the values to reject, okay, your awareness to the context itself may pose another challenge. But this is really an expectation, okay, so we need to actually practice it as well, okay? If there are no issues, then could you please pass your homework down to the front?
Right. We pass it to the floor.
Yep.
This part.
Yep.
Start a new one.